So, it's a little common, isn't it?
Squirrel.
Okay, squirrel. Squirrel. So, the first person to watch the video and to email me or tell me the word squirrel, you can have a little Debbie snack on me. So we'll see who. Don't tell him. Just like last time we didn't tell Callie, did we?
Yeah, and it was literally the one time I didn't.
Yeah.
Every other day I was gone.
And who else was gone? Somebody else was gone too. Paige. Paige didn't watch it. She didn't say that. It was avocado was the word, right? Armadillo.
I didn't.
Okay.
Yeah.
All right. Very good. So there we are. All right. Well, let's get started and let's learn the cool things. This is a graphic organizer to kind of help prime your brain for all the things that you need to know for this unit. And the first thing we want to do today is we want to graph these polynomial shapes. Super cool to see what these graphs come out like. You know what first degree graphs look like. They look like that. What do second degree ones look like? Yeah, good. That was from last unit, right? How about third degree? Addison was like, I know that's true right now. So the cool thing about third degree is it can actually have a couple bends in it as well. So it doesn't have to be just that kind of skinny snake. It can actually have some full bends in it. And then as we get to fourth degree, it actually looks a little bit more like the second degree, but it has a few bends in it. So it actually looks something like this. Maybe you want to guess which one the fifth degree looks like. Like the third degree. It's like, how do we even graph that kind of stuff? That's what's beautiful about this unit. Is it's really not that difficult. It all comes together. It's real pretty as it works out. The one thing I want to share with you about this is you notice as x is positive, what happens to the y value? It gets bigger. And as the y value is negative, what happens to the y value here? Negative. Notice how that's the case with all the odd degrees, but it's not that case with the even degrees. Why is it that the even degrees, when you have negative x's, you get positive y's?
They get squared, so you have to have a positive.
Yeah, if you square a negative, you're going to get a positive. You take a negative fourth, you're going to get a positive. We've kind of exhausted this class, many conversations about negatives and positives, haven't we? I mean, that's so much of the indicators between the shapes that you get. So that's kind of cool. What I'd like you to first look at is the number of, we call these things extrema. They're maximums and minimums that sit within the graph. And how many kind of bumps does this one have? None. How many does this one have? One. This one? Two? Three? Four. So suppose I had n degree, how many bumps could it have? N minus 1. So given a polynomial degree n, there are at most n minus 1 extrema. And it says at most because you don't have to have, like for example, the third degree one, you say, well, it looks like there's 2. It doesn't have to be 2 because I could draw another third degree polynomial that look like that. That doesn't have any extreme at all, does it? Okay, so it doesn't have to have those 3. Okay. All right. Next thing that I would like you to, I'm going to kind of go off cuff here and try to heighten our learning from previous years that maybe didn't work out as well. We're not going to use this table. I don't like this table anymore for your usage. I want you to look at these shapes, okay? As x goes to the positive, y goes to the positive. For all of them, doesn't it? Okay? I'm going to show you. So as x goes to positive, the graph goes to the positive. Okay? I'm going to draw you the negatives in this situation so you can kind of see what they look like. Obviously, the line goes down. The parabola goes upside down. The cubic goes like that. The quartic goes like that. And the quintic goes like that. So you can see that we have the red are the positives, the blues are the negatives. So focus on the red ones again, okay? The positives, as x goes to the positive, what happens to the y value? It goes to the positive. Now focus on all the blue ones. As x goes to the positive, y goes to the negative. Everybody see that? So polynomials, the way that they end, we're talking about how they end, as they go that way, If they're positive, they end up. If they're negative, they end down. Got it? Okay, so we're going to write that down right here, okay? As x goes to, so this is for positives. As x goes to infinity, y goes to infinity, meaning it finishes up. Does that make sense? Okay, let's look at the negative ones, okay? As x goes to infinity, what happens to the y? It goes to negative infinity. It goes down. Okay, that happens for all of them, right? Okay, now let's look at another thing. That's probably the most important thing you can learn today. If it's positive, it ends up. If it's negative, it ends down. Okay, let's look at how it starts. So back here at negative infinity. Okay, here's what's interesting to find about how it starts. Okay, look at all the even ones. You notice that the even ones start and end in the same direction, don't they? Like the red one, if it finishes up, it starts up. Here, the parabola, if it starts up, it finishes up. But look at all the odds. They all start and end in opposite directions, don't they? They start and end in opposite directions. And that's the next piece we want to write down is this. Even start and end the same. Odd start and end opposite. I think I have the test on my desk.
So when you say like they start and end the same, it's like they're positives and negatives.
Yeah, so notice how it starts up and it ends up. Whereas for this odd, it starts down and it ends up. Opposite for the odds, same for the evens.
Okay.
Good? What's that? Okay. All right. The last piece you need to find out before we try some examples, and it's okay to be a little bit confused about this right now. We're going to apply all this learning to a bunch of examples, and there's going to be a lot of clarity. And what we want to talk about is a single root, a double root, a triple root. And a single root is a graph that simply just crosses through the x-axis and it looks like a line. A double root, when it crosses the x-axis, it looks more like a parabola. That will be an example of a double root shape. And then a triple root is going to look more like a cubic. It's going to do that kind of thing right along the x-axis. If you don't have your calculator out yet, take your calculator out. It's one of my favorite parts of the day. It's pretty cool. All right, Ava, looks like a pretty complex polynomial, doesn't it?
Yeah.
Like, that looks like something that, like, whatever the equation for that is, would be nearly impossible to come up with.
Okay.
But yet, in just about 1 minute, you're going to know how to do it within a matter of about 10 seconds. This is a very easy polynomial to be able to graph and come up with, and you guys are going to help me do it. You already know how to do it. You just don't know that you know it yet. So watch. What is that? A single root, triple root, or double root? What do I have right there?
Triple.
Everybody agree it's triple? Because what shape does it make right there?
Oh, okay.
See it? And it goes through -2. So therefore, the polynomial that maps that shape is going to be x plus 2. And since it's a triple root, it's cubed. Everybody see how -2 is a solution? So therefore, x plus 2 is the factor?
Why is it a positive?
Because -2 is what you would plug in to make 0. This is where it crosses the x-axis. That's where it's equal to 0.
Okay.
Okay? Single root, double root, triple root.
Double.
And where does it go through?
1.
So we got x minus 1, quantity squared. Single, double, triple?
Single.
Single. And it goes through? So x minus 4. Single, double, triple?
Triple.
Triple. X minus 7 to the third. That's the equation for that polynomial. And just to prove it, let's graph it on the calculator and see if we can come up with that exact same shape. I'm going to take out my calculator as well. And I will start from scratch here. And I'm going to type in x plus 2. And I believe that we raised that to the third power. And then the next one was x minus 1. Is that correct? One thing I don't like about this is I can't really bring this screen up and the other screen up as easily compared to the other software that we had. And then the next one was x minus 4.
Yep.
And then the next one was x minus 7 cubed. If you think about that, that's cubed. Then squared would be 5th, 6th, 7th, 8th. This is a 9th degree polynomial. A 9th degree polynomial. And instead of pressing graph, because I noticed from our picture, I noticed that the window is a little bit different. Because it's got some really big highs and some really, really low lows. So I'm going to change my window to x being negative 4. My x max being positive 8. I got my y minimum at negative 50,000. Sounds like my dad. Got my y max at 40,000. Sounds like my number of YouTube viewers. And then my scale is 10,000. That means I'm going to have a tick mark every 10,000 on my y. And if you press graph on this, does that look like the graph that you have on your paper?
Yes.
We came up with that quickly. Some of you do not have that same graph, or you entered them all in individually.
Oh.
We put them all in on one line.
Okay. Well,
that's all right, Bea. You're good to go. All right, so let's try some examples then. You guys can understand what your assignment is going to be like today and the things that you're going to be asked to do. So you can turn in your notes to the section that looks like, where is it? Oh boy, oh boy, oh boy, where is it? Anybody see it? Where'd it go? Oh, there it is. Okay. Okay, we go to this first one right here, and graphing polynomials, it's already in factored form. So I struggled right away the first few times I taught this to figure out what's connecting for students. I find that this is an organizer that generally helps them, is first deciding what's the degree going to be when you multiply that out. First degree, second degree, third degree, fourth degree.
second.
Yeah, everybody agree you're going to get an x squared, so it's second degree. And will it be a positive x squared or will it be a negative x squared? It's going to be a positive x squared, so it's positive. Hey, we know that all positive polynomials end going up. And we know that those that are even start and end the same. So it's going to start up and it's going to finish up. And that's a process I go through each time as I try to teach kids, kind of how you think of it. But I know that this goes through what two values on the x-axis? 2 and negative 3. So I plot negative 3, I plot positive 2. I draw my shape. We already knew how to do that. I mean, that was a parabola. It was like from the last test, right? But that's easy, Mr. Jens, right? Let's look at something just a little bit different. What degree is that polynomial, number 2? Third degree. When you multiply that all out, would it be positive or negative?
Negative.
It's going to be negative. We know that all negative polynomials end going down. and we know that they start and end. If they're odd, they start and end opposite, okay? So if it ends down, it will start up. And I know it's going to go through -4, +1, and +5. So as I make my axis, I plot 1, 2, 3, 4, 1, 2, 3, 4, 5. -4, +1, +5. Notice how this one starts up and it finishes down. Good chance that they're not going to watch a video yet because they don't have the notes yet, right? So they're going to wait till Monday and then they'll get something, maybe go back and watch it. It'll be interesting. But we won't say anything. Try number 3 on your own. It's kind of a bad shape, isn't it? Yeah, kind of embarrassed by it. I'm going to do it again. So, that's better. Take pride in my polynomial drawings. I won't be too critical of your shapes. Any questions how I got that?
Can you explain how you get whether it's a positive or negative star?
Yes. So you can see here that when you, first of all, you see that's x to the third.
Mm-hmm.
And you see when you multiply these out, that x times x times x will give you a positive x cubed.
Okay.
So these numbers don't have anything to do whether it comes out to be positive and negative. Only the x's indicate whether or not it's going to be positive or negative. All the x's are positive, so I multiply will be positive.
Where do you start counting?
So it will end up because it's positive, and because it's odd, it will start and end in the opposite direction. This indicates the start. The end is indicated here. The start is indicated here. Odd is opposite. That better? All right, let's start to get to a little bit more. Yeah, hi.
So if the number is odd, that's how you figure out if it's odd or even?
Yeah, if the degree, yeah, exactly.
Okay.
Yep. So the next one, what degree will that be if you were to multiply it all out? It would be the third degree. Will it be positive or negative?
Negative.
Be negative due to this negative right here. Because it's negative, it will end down. And because it's odd, it starts and ends opposite. So it will start up. There we have it. Now what you notice about this one is this one's being squared. So therefore we have our first double root. This is a double solution here. So that means I'm going to put a D here for double solution and an S here for single solution. And this is where you kind of have to just kind of try to see if you can figure out what the shape looks like. Some people struggle with this. Some people it comes very natural to. I just try to show you a bunch of examples, see if we can get, but I know it starts up there because it says starts up, and I know it finishes down because that's what that says right there. But we have to fit in a double root there and a single solution there. So what's going to happen is it's going to come down to this spot, and it's going to make kind of a parabola shape, and it's going to go through there. Double root at -4.
So the double root just means it'll
Bounce off, does not pass through. Yep. Touches and makes a shape like a parabola right on the x-axis. We'll look at a few more double roots and single roots so you kind of get the hang of it. We want to get through this page, and then I can hand you your tests. What degree will number 5 be?
4.
This will be a 4th degree. When you multiply it out, will it be positive or will it be negative? It will be negative. Why will it be negative, Paige? Yeah, so you have a positive x, a positive x, a positive x, and then a negative x. So as you multiply them all out, I have a negative value. So that tells us what?
Down.
It's going to end down. And since it's 4th degree, that's even, so therefore it will start and end the same. So I will start down and I will end down. Are there any double solutions here, or are they all single? These are all single because I have a positive 5, a negative 5, a positive 3, and a negative 3.
Why is that a positive 3?
What number would you plug in to make 0?
Oh, 3.
Yep, so 5 is the number you plug in there, negative 3 is the number you plug in there, 3 is the number you plug in here, and negative 5 is the number you plug in there. That tells us where it crosses the x-axis. So as it starts down and finishes down, they're all single solutions. So I have that shape.
So when it's like a double, does that just mean it wouldn't cross?
It would not cross. It touches and bounces back. So the next few here that we do, we're going to do 1, 2, 3, 4, 5 more, and they're all going to have single and double root, or single, double, triple root type situations. So that will start to clarify itself. All right, what degree do we have here? This is a 5th degree polynomial. If we were to multiply that all out, would it be x to the 5th or would it be negative x to the 5th? Yep, so it is positive, which tells us it will end up. Because it's odd, it starts and ends opposite. Yep, so this starts down. So it's going to go through 0 and then 1, 2, 3, 4. It's going to go through 0 and 4. Notice I have what kind of a solution at 0?
Single.
A triple root. And at 4 I have a double root. So you got to kind of think about how that looks. And don't be afraid to make a mistake. But right now on your own, try to draw it so that it has a triple and a double. Studies show that you learn a lot more if you try it and then I show you, as opposed to me just constantly showing you. So try. Don't be afraid to make a mistake. Might have to re-sketch it, and that's okay. Ethan, what movie are we watching today?
Lost Boys.
All right. Okay, I'll sketch it. I start down here. It's a triple root, so I flatten out and pass through. And I come back down for the double and back up. So how'd you do?
Good.
All right, good.
Wait, how does
Okay.
that look like a 5th degree? Wait.
You did it right.
No, it does. It's just really small.
And to be clear, so Callie makes a really good point here about the whole 5th degree thing. If it's 5th degree, how many extrema could it have?
4.
4. Does it have 4? No, it doesn't. It has 1, 2. So at most, it could have 4.
Oh, okay.
So you have 2 here, but 2 more get used up right there. You know what I mean? So I just see 2. So it doesn't have to have 4. It can have less than that.
And that's
Okay.
like the little loops they show.
Yeah, kind of the bumps. Yep, exactly. Number 7. What degree is this? 4th degree. Is that going to be a positive or a negative? Yeah, negative. Ava, what do you see there?
Negative x.
The 2 minus x, that's going to make it negative, so therefore it's going to end down. And since it's 4th degree, it starts and ends same direction, so it's going to start down, it's going to end down. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I can plot positive 5 and negative 1 and positive 2. And notice how you have a double root at 1. Negative 1, excuse me. See if you could draw the shape without me drawing it for you. Okay, I'll draw what it should look like. That's what we got.
Does the amount, like, that I curved down here,
Excellent question.
does that
So
affect anything?
this whole, like, a lot of people wonder, like, how high or how low do you go?
Yeah.
We don't really have any way to determine that right now. That's really a calculus question that we get into that in about chapter 4 in calculus next year. But finding those locations, that's kind of the next most important thing. For example, this would be like, hey, how do we minimize cost or how do we maximize profit? And finding those is a different ballgame all here. So I don't care how high or low you draw it. I just want to draw that or see that general shape. What's the degree here? 5, positive or negative? It is negative. So it's going to end down and it will start up because it's odd. Is doing a great job of catching on. I've got solutions of positive 4, a solution of negative 2, and a solution of 0. And I've got this interesting triple root action happening at 0. See if you can draw it with a triple root. See what you can do. Oh, Paige is feeling confident. She's wearing her senior sweatshirt today. She got through her CNA stuff yesterday.
Yeah.
She's getting caught up on her homework. She got a good plan for the weekend. Good job. There we go. Let's do 2 more. Number 10. You try it all on your own. Do number 10 all on your own. Yep, skipping number 9. Never liked 9. I have a good story about number 9, but I don't know if you guys are going to laugh. I'm afraid you're going to judge me.
I'll judge you.
I subbed for your brother today.
My brother?
Yeah.
Did you?
Class. I had to kind of yell at the class.
Was it because of him?
No, but somebody in the class made a comment, and I thought that it was a very, very inappropriate comment. Turned out it wasn't, but I didn't really. If you would have seen the situation, you would have thought the same thing. Trust me. So if he says at home tonight that Mr. Gans is really scary and yells, that's why. I asked one of the classes today if I would have been cool enough to sit at their lunch table in high school, and they said probably not. I said why? Because they said because you probably just sat around and did math all the time. All right. Oh, and would I have been cool enough to sit at the Ava Murray lunch table?
Probably.
Probably. Oh wow. All right.
Our room is pretty packed.
All right.
We're so squeezed.
Okay, so I get a yes from Ava, and I get a from Nevaeh. I get nope. There's not enough room.
Well,
So,
no,
interesting. All right.
no, there is
Claire,
but
Claire,
we
is
made
there
room.
enough? How about your table? Can I sit at your lunch
I
table?
don't know, we're kind of packed.
Okay, all right, Gunner, help me out, dude. Sure, all right, I got a friend. Dirk?
No.
Oh, wow, got big time right there. All right, let's do the last one again. We'll do number 12. Number 12, positive or negative? It is negative, and it is going to be x to the first, second, third, or fourth? X to the third, so it's going to finish down,
Sorry, finish.
and it will start up. There you have it. Draw my little graph. I plot 1, 2, 3, 4, and 1, 2, 3, 4. Positive 2, negative 4, 0. And they're all single roots. Nice, easy shape. Kind of how we started. What do you think? Not too bad, right? Okay. Good job. So let's look at the homework, which, again, the homework packet seems twice as long as it actually is. Okay? Don't give him this against a hard time.
A blank sheet.
I know I have to have blank sheets of the normal one goes back to back so it separates properly. But so that there is so much wasted paper in this, I feel bad. I feel bad. Okay,
So
yes.
there's 14 problems.
So, yeah, so just to be clear, the very first, the first ones, you can see that they are all factored for you, okay? And then the next page, you can see that they are not factored for you. So you have to go through the factoring process. You are excellent at factoring. That shouldn't be too much of a problem for you, okay? Been a busy week for me. I've had tests in all of my classes. I am grading the calculus tests as we speak, trying to update things right away. It is going to take just a little bit of time before I get these answers posted, but if I recall correctly, I think I made an answer key of just the answers to post online last year for this unit, and maybe I could do that right away. So, once again, what is the code word for the video?
Squirrel.
Squirrel. See if anybody watches it.